Hello and welcome. We're going to go over this problem today called rotate array, and we're going to solve this problem via the UMPIRE process. So the problem is given an integer array nums, rotate the array to the right by k steps where k is non-negative. So what does that mean? So let's take a look at the understand step of this process. So understand. So what do we understand by this? So we understand that the input is an integer array, A, and the output is a rotated array, A, k steps to the right. So what does that mean? So let's just take a look at these examples over here. So if we have the nums array 1, 2, 3, 4, 5, 6, 7, and we have k equals 3, oh, I forgot about that. So we have inputs integer array A and k, non-negative integer. And we wanted to rotate, so we want to rotate this array by 3 steps. And so if we rotate the step to the right once, then we just take the last element, 7, and put it into the front of the array. So we get 7, 1, 2, 3, 4, 5, 6. And then if we want to rotate it to the right 2 steps, then we take the last element here of the previous step, 6, and we put it to the front of the array and then move everything down by 1. So that's 7, 6, 6, 7, 1, 2, 3, 4, 5. And then the third step, if we want to rotate 3 steps to the right, then we take from the previous array the last element 5, and we put that to the first element of the array, and we move everything down by 1. So that gives us 5, 6, 7, 1, 2, 3, 4. So that's an example of rotating an array by 3 elements. So here's an example 2 where we rotate this array -1, -100, 399 by 2 elements. So the first step of rotating to the right is we take the last element, 99, we put it to the front. So 99 to the front, then we shift every element to the right by 1. So we get an element array 90, 99, 91, 103. And then if we take the second step to rotate it twice to the right, then we take from the previous rotation the last element of the array and we put it to the front, so 3. And then we shift everything down by 1, so we get 399, -1, -100. So that's an example of our understanding of rotation of an array. So now that we understand how to manipulate these arrays, we can go to the match step and ask what kind of similar problems we have to compare this to. So similar problems are like um, array slicing and replacing array through loop. And also, since there are different ways to actually go about solving this problem without slicing or array looping, we could, or actually, I think all of it requires a loop, but it's embedded into the insertion method and the pop method. So we can use these kinds of methods to go about solving for this problem. So next, we're going to go over a broad view plan. So we're going to use array slicing and replacing array through a loop to be able to do this problem. So what we're going to do is we're going to take the array. So just give an example: 1, 3, 4, 5, 6, 7. So we're going to, so with k equals 3, what we're going to do is we're going to take this array and we're going to cut it. So the solution here is 5, 6, 7, 1, 2, 3, 4. So what we're going to do here is we're going to cut the array in half. So we're going to take the first part where it ends, and we're going to take for the second part where it began and trailed off, and we're going to cut it, and we're going to find uh, an array slice to describe the first part of the array and the second part of the array. So the slicing method is going to be given by, so this is array slicing from length array minus k plus array length array minus k. So this is the first part of the array up to length array minus k, and this is the second part of the array up to, from length array minus k to the end. So that's the formula for this cutting up this array, and then we're going to set this equal to an auxiliary array, and one by one we're going to copy the elements back to the original array. So set this equal to B array and copy array to B, or B array to array. Okay, so now we can implement this plan. And we first start by well, first we're going to we're going to we're going to put k into a bracket in which it's less than, or it's less than length, and so if we move by any multiples of the length of the array plus some skew element k, then we're going to go back, and it's still going to move with respect to that skew element. So we can put any larger k value that's greater than the length of n to be something that's some elements that is within that bracket. So we're going to set k equals k mod L1 length length nums, and then we're going to make this B array, which is going to be the array for nums from length of nums minus k to the end plus nums from the beginning of the array to the length of nums minus k. And then for I in range, length B array, length nums, and one nums I equals B with the length I. And that's it. Solution accepted. The solution is accepted. So that's the solution to this problem rotate array. So now if we take a look at Python tutor, and we can step through the review of this process. So we can go through printing the rotate array, and it just sets up so that we enter the array and we set the k value, and then it goes into setting the B array, and the B array is set, and it's a slicing process, so it's put to get the numbers, and then we go into the length nums loop to set nums I back to B array, and that's for each element I to length nums, and then we output, and that gives us the rotation of the array 2, 3, 4, 1. If we start with 1, 2, 3, 4 and rotate 3 times to the right. Okay, so now that we're done with the review, now we can go back to evaluating this problem. So the evaluation is that we have a time complexity of O to the N, and that's just because we run through this range of length nums to copy the array. And then we have space complexity of ON because we copied this this array, or this rotation of the array onto B array. And so we have a space complexity of ON. So now that we have a good understanding of this problem and evaluation of it, we can end it here. Thanks for listening.